Speed is the key. Okay. But what is speed? Can you define speed? Specifically, computer speed. We can't achieve it without understanding. I don't see many people understand and explain it clearly. But don't worry, we'll work on it. Let's say we are buying a modem, M100, from either restaurant A or restaurant B. M100 is made by Fujitsu, and it's the same performance, same quality, same everything, except for the services provided by the company A or company B. It happens very often, right? And it doesn't have to be modem, but it happened to me recently, that's why. And you are going to choose A or B, who to buy from. Now we know that company A closes 20,000 incidents a month. 20,000 incidents means basically it's questions, inquiries through a phone or email. You ask them how to connect the modem or set up the modem because you don't read manuals. B closes 1,000. So which company do you want to go? It seems good because they have more capacity. They are most likely selling a lot more. So we are tempted to go to A. So do I. But wait a minute. Your friend told you, or from Yellow, you know that A closes one incident in over 3 days. That means you call them because you don't know something, and you're greeted by a recorded message, and you leave your voice message, you responded in a couple of days later, and eventually solved in 3 days. That happened very often in America, I know that. And B closes one incident over one of that means maybe you are able to talk to a human operator right away, and then they solve your problem in just 1 hour. You don't want to wait for 3 days to install a modem. You should go to B. I will go to B. So there are different types of performance speed involved in computer too. This type of performance speed is called throughput, capacity. And we use a lot of different terminologies, a little bit different, but basically the same idea. While this type of performance speed is called response time or latency. So we have latency, throughput, response time to inputting Goro, amount of log that can be done in any time. The point is, they're different. Sometimes they're rated, but very often they don't always come together. That's my point. So you need to understand your job needs which or both. Let's get back to flash. Should I tell you how computers make a decision? The applications, of course, know everything about every rule of stock chart reading. And they use big data. I mean, they check all the charts tweets you send out and pick keywords, decide bad rumor, good rumor, bad news, good news, weight them and make a decision. It's huge amounts of calculation within a second or two. So they definitely need a capacity throughput. That throughput good enough? No. It is not good enough because if your computer makes a slow decision like company A, even if it has enough capacity, like your computer will sell your stocks at the bottom because decision was slow, and buy them back when the stock price will recover. You're going to lose a lot. If your computer makes much quicker decision, your computer will sell your stock before it gets down and buy them back at the bottom. So you will make $1 trillion in 10 minutes. So you know what I mean? It's a response time is very important. Latency. is latency and throughput. I would like you to pay more attention to latency part, because most computer benchmarks measure only throughput. So people tend to think about throughput. That's our speed. Speed is money, I mean. Response is money, literally. Don't save a million to lose a billion. By which I mean, if you get the cheapest computer, whatever that is, tons of them, we can still achieve high throughput. It's like a rowing boat, one-man boat, very slow, but if you had a million rowing boat, you can still carry 1 million people. Doesn't make much sense like that. Now we know the challenge we're facing. We also know that speed is key. I'd like to show you how Fujitsu technology will help you speed up 12C and big data. Big data is latency and throughput when you start that. If we want to implement latency and throughput in the world of computer, your platform must have big memory, high-speed data transfer, and high-speed processing capability. Big memory is especially important because memory is a million times faster than hardware drives. I replaced all my personal hardware drives with memory. My laptop, my desktop, they don't have hardware drive anymore. In this chapter, I have a few demonstrations using Fujitsu M10, so it's a good time to talk a little bit about M10. M10 is Fujitsu's flagship computer. We historically give M names to all flagship computers. M is from one box, one socket, commodity killer to 16 building blocks, 64 sockets, 64 terabyte, supercomputer class server. Seamless. All compatible. And we have 3 design goals. 1, big data ready. And it also must be 12C ready or heavy software ready. Number 3 is it should be a very nice central platform, consolidation platform. It works very well with Exadata, Exalytics, Exacomputers as a central computer. Use those in special computers, get the data and you edit it, you do whatever you want. And also this is a great consolidation platform because 100% compatible with existing Spark platforms. So you can bring in all the programs, applications, database applications, non-database application, everything. Your running cost will be much smaller. This shows you in the chart. If you look at the center square, it's all over red. Red means warning. But if you have more data, you can say that in the center of the area, it's purple, great. That triggers evacuation order. And the plate must be vacated. With less data, evacuation order will not be issued. So what we can say from this is that it's very important. Big data or big data application is very useful. Can help human lives only if we have big enough data. If we don't have big enough data, the results could be useless or even misleading. And we also know that Fujitsu M10 is the best platform for this type of application because we tried this with the commodity servers. With the laptop commodity servers, it has enough throughput, it can reach same results, but it takes too much time, like 30 minutes, 1 or more than M10. It's no longer real-time evacuation order, too late. The reason is, like big data case, if you change a bit of parameter, all of a sudden you receive 100 times more data. So your server, your computer must be very flexible, must have room to grow. So everything can do that. Commodity servers can't. I'm changing the subject to 12C. Please don't mix up 12C and big data. They're different in terms of data structure, but they have something in common. Let's see. 12C is an innovation. It's a new database. It has tens of new features. If I'm to pick two major features, that would be in-memory database and pluggable database. In-memory database has been explained by Mr. Allison the day before yesterday, so I don't go into details. The 12C is an innovation, but it's very heavy software, so you need a very good high-performance platform. Plus, some special features such as big memory. I don't need to explain big memory and pluggable resource. I will show you how pluggable resource of M10 would work with 12C using this animation. What's good with M10 is you can introduce M10 as a single box which still has 4 processors and 4 terabyte maximum memory, so it has a great capacity. But if you're running out of resource, you can add another box until 16 boxes with combination of building block and core activation. You can define your system in detail. You don't have to waste a penny. If you go with IBM, you have to buy the largest box or the smallest configuration. You don't need to do that with M10. The good thing is M10 is a single computer, no matter how many boxes are connected. It's a single, not like many commodity computers. So it's very easy from software point of view. You don't need the extra software or anything. You can create just a single container database. It's easy to maintain. Great integration. So in the real world, how we can add a computer. This is a video, short video, and I'll show you this video. We use the Ops Center, which is a standard Oracle software, to define the configuration. It's funny, I didn't expect it. It will make system administrator or DBA's life much easier. I was planning to do the live demo on the stage, but I changed my mind. You know why? Because it's boring. Not just boring, super boring. The operation is more relatively easy, but it takes 30 minutes, 1 hour to be honest. But you don't have to worry about it because your CIOs and executives, because the users of your service will never know that you added the computer or deleted your computer, because this feature is called dynamic reconfiguration. You don't have to stop your computer. Without stopping your computer, we can add boxes, delete boxes. This is a great feature. Only Fujitsu can provide this feature at this level of computer. You will love it. Some customers really love this feature.